Hey, today I'm going to show you how to make a thermocouple using a thermocouple welder from Thermocouple of California. This is a TIG welder inside a box contained specifically for welding thermocouples. It uses argon gas. Inside it has a TIG welding head, argon gas port, so on and so forth. Today we don't have any argon gas, so we're just going to use canned air to blow out the oxygen and contaminants in there. It helps some. It's better than nothing at all. So anyway, we will start with Type T Teflon coated thermocouple wire from Omega. The part number on that is TT-T-30-SLE. It's copper and Constantine wire. It said it's a 30 gauge. When you strip it, you want to strip about 3/4 of an inch to half an inch to 3/4 of an inch. And you want to use the strippers in such a manner that you'll get all three jackets, because you have three jackets on here, one on each wire and then one to contain both wires. So once you get done stripping it, you have a piece of wire with two bare wires. Let's say one's copper, one Constantine. And then you want to put it into the wire holder. This wire holder acts as a ground for your electrode on your welder. Take some can air, blow it out on the inside. And they say it should use argon. Turn it on. You want to center that. Your electrode needs to be kind of pointed too, but that's good. You put the wire all the way in there. You want to make sure that the insulation on the wire doesn't touch the copper on your wire holder, otherwise you won't get a good weld at all. So once you have that sit in there, just push it into the welding cavity, and push the weld button. If you don't see an arc, it means it didn't weld. So apparently I don't have the wire holder set properly. What I'm doing now is readjusting my electrode on the welder. The wire got it too close to the electrode and it just latched on the end and just pulled it right out. So I'm turning around. Your electrode has two ends on it. So instead of taking the time to clean the one end, we're just going to just go ahead and turn it around, reinsert it, and then adjust it to the proper depth using the depth adjustment tool. And there's a tightening knob on the back, which is basically the head of the back of the head of your TIG welding head. Once that's done, you want to make sure you re-strip your wires, cut off any excess wire that's not good. Make sure you re-strip so you got good clean wires right there. Turn it back on. We want to reflush the system wire holder into the welding socket. There we go, just like that. Now you have a little thermocouple bead. This one turned out really well. It's kind of almost a gold color, and that's what you're looking for. It means you got a good clean weld on your bead. This is good, solid, nice and round like it should be. Now what we're going to do with this, because of our application, is we're going to mash this ball on here flat. That ball happens to be your actual thermocouple. Now you can mash this ball flat any way you want. I just prefer to use this particular pair of pliers. It works out really well to mash that thermocouple flat, and you'll see why here in a moment why I'm doing this. So there you have a flat, it's a thermocouple. Okay. Okay, now, the reason why I smash this thermocouple flat is because what we're fixing to do with it now is we're going to super glue it onto a DIMM so we can do a thermal characterization of a set of DIMMs for a high-end server. So, go ahead and get a DIMM here. The first thing we want to do is, now you can put it on any chip on here. For our testing, what we normally do is we'll put one on each end here, or at one of the either ends on both of these here, and one on a buffer. But today we're just going to put one on here just for demonstration purposes. So I start off with Loctite 7452. This is an accelerator cleaner. I go ahead and spray that on there like so. Get really nice and clean and wet and ready to go. And in the meantime, there's a stainless steel probe. I use the 45-degree angle probe. It seems to work out best for me, but you can use whatever you want. What you're going to be doing is you're going to take this thermocouple and you're going to take the end of this probe and hold this thermocouple down on top of there after you put the super glue on there. You take the super glue. This is Loctite 382 instant adhesive. It's a large bottle that you can buy. Just about any super glue will do the trick if you're doing this just at home. You want to make sure it's viscous enough to do this. So the gel probably wouldn't work. You want something that's a little thinner. So you take this and kind of get it all in there, and just keep it moving because it'll solidify if you don't. And then you take the probe and you hold it down right against the DIMM like so. You wait a few seconds for that to adhere to the top of that DIMM. And you pull it off. That's all you got to do. Just let it dry, and that's ready to go to take measurements on. Now your measurements on that are going to be fairly accurate. As far as conductivity as heat is concerned, I don't know if the super glue on there is even negligible in that respect.